classical definition of probability is nothing but it is favorable number of cases divided by total number of exhaustive cases, that is m divided by n, right? Sometimes this occasion, if we can say that odds in favor of E are m is to n minus m, because m are in favor of E and n minus m are against E. So we can write odds in favor of E are m is to n minus m, or we can say that odd against E are n minus m is to m, right? So now sure and impossible event. So probability, if probability of event E is 1, then we say that it is called sure event, right? If the probability of E is equal to 0, then E is called impossible event and it is denoted by phi. And sure event means if you say throw a die, suppose you throw a die, so we want that what is the probability of that a number is less than 7. So that means there are 6 possibilities, 1, 2, 3, 4, 5, 6, and exhaustive events are also 6. So 6 divided by 6, so 1, probability is 1. So if impossible event, we can have an example as suppose we throw a die and we want that what is the probability that of getting a number greater than 7. Yes, 6. So because the die has only 6 faces and we cannot have any number greater than 6. So it is an so favorable event is 0. So it is an impossible event. So probability is 0. Probability of its impossible event is always equal to 0. Now we have examples based on probabilities on the first definition, on the classical definition of probability. Now first example, let us consider two unbiased dice are thrown. Find the probability that both the dice show number 1 the same number. If the first dice show 6, number 3, if the total number on the dice is 8, the total number on the dice is greater than 8, the total number is on the dice is 13, the total number of the dice is any number from 2 to 12, both are inclusive. So I have given an example, but I have not given their solution, but I will just discuss this solution of these problems and you can solve them. Okay. Now, when we say that two dice, unbiased dice are thrown, so that means we talk that they are simultaneously thrown. So one dice has 6 faces, 1, 2, 3, 4, 5, 6. Similarly, second die has also 6 faces, 1, 2, 3, 4, 5, 6. So when we throw the two dice simultaneously, the possibilities are 6 square, that is 36 possibilities are there. So our exhaustive number of cases will be 6 square, that is 36. So how we can count them? We can start first, we can fix first suffix as 1 and then second is 1 to 6. So 6 possibilities are there. Similarly, fix 2, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Similarly, we fix the first 2 and then we can move 1 to 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Similarly, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 6. It's the same. Continue in this way, you can have 36 possibilities. So these are the total possibilities when you throw two dice simultaneously. Now, you want that the probability of the same number. Same number means you get 1, 1 on the both the dice, 1, 1 on both the dice, right? Or say
Yes, sir.
it is the same number. If we say 1, 1 is the same number, similarly you can have 2, 2 as the same number, 3, 3 as the same number, 4, 4, 5, 5, and 6, 6. That means favorable number of cases in this case will be 1, 1, 1, 2, 1, 3, 1, 4, 1, 1, 1, 1, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. That means 6 favorable cases and exhaustive cases are 36. So probability of the same number will be 6 by 36, that is 1 by 6. Now second part is if the first die is so 6. So because the exhaustive cases in all the case will be remain the same. Only favorable will change in each case. Right? Now if the first die shows 6. That means it can show any on the second dice. So it can, the possibilities of favorable number of cases will be 6-1, 6-2, 6-3, 6-4, 6-5, 6-6. That means 6 possibilities are there. So total favorable cases will be 6. So probability in this case also 6 by 36, that is 1 by 6. Next, the total number of, on the dice is 8. So 8 will come, how it will come? If we have 6 on the first dice and then 2 on the second dice. So 6, 2 will be becomes 8. Similarly, 5 on the first dice and 3 on the second dice, 5, 3, 8, then 4, 4, 8, then 3, 5, 8, and 2, 6, 8. That means how many favorable cases in this case? There are 5 favorable cases.
Right.
6, 2, 3, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6. So 5, so the probability of getting sum on the dice is will be 8 is 5 by 36. So probability of getting the total of the number on the dice is 8 by 5 by 36. Similarly, total of the number on the dice is greater than 8. So greater than 8 means it can be either 9 or it can be 10, it can be 11, it can be 12, right? So only these are the numbers which we can get when we throw 2 dice, which are greater than. So in this case, we have to find the favorable of getting some 9, favorable of getting some 10, favorable of getting some 11, favorable of getting some 12. So that means how you can get 9? 9 can be 6, 3, then 5, 4, then 4, 5, then 3, 6. That means 4, 4 in this case. For 9. For 10, we can have 6, 4, 5, 5, and 4, 6. So 3 possibilities in this case. And getting 11 means 6, 5, 5, 6. So 2 possibilities are there. And getting 12 is only one possibility, 6, 6. That means there are 4 plus 3 plus 2 plus 1. 4 plus 3, 7 plus 2, 9 plus 1, 10. 10. So favorable cases is equal to 10. So probability will be 10 by 36. So which is 5 by 18. Now similarly you have to find total number on the dice is 13. When you throw a die, 2 dice simultaneously, you will never get 13 because maximum number you can get as a sum as maximum number of first die and maximum number on second die, that is 6, 6, 12. So maximum number you can get as 12. You cannot get more than 12. So the probability will be, there is no favorable cases, 0, 0 by this. So this is an impossible event. So probability of this event is 0. So the probability of getting number greater than 30 is 0. Similarly, total of the number on the dice is any number between 2 to 12. So in this case, you have to count all the possibility favorable cases like 1, 1, getting 2, only you have one possibility, 1, 1. Similarly, for getting 12, you can have only 1, 1, 6, 6. For getting 12, 6, 6. So similarly, you can find 3. So 3 can be 2, 1, 1, 2. And 4, you can get 4 as 3, 1, 2, 2, or 1, 3. Like this, you can count all the favorable cases, add them. So you will get favorable divided by total. You will get the probability of getting a number between 2 and 10. So you can solve this problem, okay? Is it clear this example? So you can solve this example. I will only write the example, solution you have to solve yourselves, right? I am explaining the solution, but you can do the writing work yourself. Now example 2 is 4 cards are drawn at random from a pack of 52 cards. Find the probability that number 1, if one card is a king, second card is queen, third is jack, and fourth is ace. That means each card is of different type. So when we draw cards from a pack of cards, then total combination will be 52C4. That means the total combination will be 52C4. So, right, when we draw the cards from the pack of cards, then we use combination of the cards. That means, so there are total possibilities 52C4. Right. Now we want that one card is of a king, and we know that in a pack of cards there are four king. So we can draw one king from four kings. So for all possibility will be 4C1. And similarly, there are four queens. We can draw one queen from the four queens. So possibilities are 4C1. And jack, we can have four jack in a pack of cards. So we can draw one jack in 4C1 ways. Similarly, there are four ace. So we can draw 4C1. So multiply them 4C1 into 4C1 into 4C1 into 4C1 divided by 52C4, which is the probability of getting a king, a queen, and a jack and an ace. So this is how to running out of. So now second example is four cards are drawn at random from a pack of 52 cards. In shuffling a pack of cards accidentally dropped, find the probability of that the missing cards. So this you should try. Now fourth example is what is the probability that a leap year selected at random will contain 53 Sundays. No leap year we know that a leap year is have 366 days, which has 52 weeks. 52 into 7 will be 364 days. Now number of days left will be 366 minus 364, that is 2 days. Now we want 53 Sundays, that means we want in these 2 days there must be one Sunday. So how we can count the total possibilities of one Sunday will be either you can have Saturday, Sunday, or you can have Sunday, Monday, or you can have Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday. Like this, we can have 7 possibilities, and favorable are Saturday, Sunday, as well as Sunday, Monday. These are the 2 favorable cases. So probability of getting 53 Sundays in a leap year is 2 by 7. Similarly, you can find the case of in non-leap year. What is the probability of getting 53 Sundays in a non-leap year, right? So this you can try yourself. What is the probability that a non-leap selected random will have 53 Sundays? Now another problem on urn. Urn means box. You can see what urn. An urn contains 6 white balls, 4 red balls, 9 black balls. And if 3 balls are drawn at random, what is the probability that number A, 2 balls drawn are white, number B, 1 of each color, none of the is red, D, at least 1 is white. So when we draw balls from the box or arm, so we first calculate the total number of balls. Total number of balls in the box are, total is 6 white plus 6, 4 red plus 9. So it will be 6 plus 4, 10 plus 9, 19 balls. Total balls in the box or arm are 19s. So we have to draw 3 balls. So here also we use the combination of the balls. Combination can be how many? Total combination possible. 3 balls out of 19 balls can be drawn in how many ways? 19 C3. So these are the total possibilities of drawing 3 balls out of 19 balls from the box. Now first problem is 2 balls are drawn are white. That means 2 ball comes from 6 white. Because there are 3 balls, 2 balls are drawn are white, and that means 1 ball may be of any color, right? So 2 balls should be white, 2 balls should come from the 6 white ball. So total possibility of drawing 2 balls from 6 white ball is 6C2. Now the remaining ball will be 9 plus 4, 13 balls. So we can draw the 1 ball from the remaining 13 balls. That is either red or black. So total red and black balls are 9 plus 4, that is 13. So one ball can be drawn from the 13 balls. So 13C1. So hence this becomes 6C2 into 13C1, and favorable cases will be 6C2 into 13C1, and total exhaustive cases will be we have a total 19C3. So divide them, solve them, you will get the solution of 1A part. Now one of each color. One of each color means one should be white, one is red, and other is black. So one white ball can be from 6 white balls, so 6C1. One red ball can be from 4 red balls, so 4C1. One ball can black can be from 9 black balls, that is 9C1. So 6C1 into 4C1 into 9C1. So this is the favorable cases. Exhaustive will remain the same, 19C3. So 6C1 into 4C1 into 9C1 divided by 19C3 is the probability of getting one of each color. None is red. None is red means all the three balls are not red. They can be either white balls or can be black balls. Okay? So that means these three balls should be drawn from white plus black. So white plus black are 15 balls. So it should be drawn from 15 balls. So 15C3 is the favorable number of cases divided by 19C3. So this is the probability of none is red. At least one is white. At least one is white means we can have one white ball, or we can have two white ball, or we can have all the three white. At least means occurrence of one of the event. One means one white, two white, or we can have all the three whites. At least one white is white means one white ball or two white ball or all the three white balls. So in this way, how will you find? First, you can find probability of one white ball, then you can find probability of two white balls, then you can find probability of all the three white balls. So one white ball means one is from 6 out of 6, so 6C1 into, and rest two are from red or black, so 9 plus 4, 13C2 plus two white balls divided by 9C3 plus, so two white balls, 6C2 into 13C1 divided by 19C3 plus all the three from the white balls, so 6C3 divided by 19C3. So add them, we can get the probability of at least one white ball. So now second other example is example 6. In a random arrangement of the letter of the word commerce, find the probability that all the vowels come together. Now it is a question of arrangements. When we have question of arrangements, then we use permutation combination. Permutation for arrangements, and combinations we use combination for when we draw balls from the box or card from the pack of cards. Then we use combinations. Here we have arrangements. So we have now we have to first count the total number of letter in the word commerce. So we see that there are two CO, MM, two M's are there, two E's are there, and RC. Four are different, 4, 4, 8. So there are 8 letters. Okay. So total arrangements of 8 letters in the word commerce. So here we say that we use the property that if we have n letters and n1 are of one type, n2 are of other type, nk are other type, another type. So we then say that then the arrangements of such can be n factorial divided by n1 factorial, n2 factorial, and dot dot nk factorial. Right? Like this, so that n1 plus n2 plus nk is equal to n. So this is how we use arrangements of the n letters in which n1 are of one type, n2 are of another type, nk are of another type. So here we have letters, of which two are of one types. Two are E's. Okay. And so it will be 8 factorial about 2 factorial into 4 factorial into 2 factorial. Now total number of cases where all vowels are together. So vowels, there are only 3 vowels. That means 2 E's are there and 1 O is there. So only 3 vowels are there.